Hi everybody, I'm Rob, and today I'm going to talk to you about building an application from scratch. This is episode 1, where we're going to be going into all the phases of project development very quickly. So the first thing we need to do is figure out a problem. The first thing that we start out with is a problem. And a problem could be anything, but in our specific case, the first thing that we have is a problem. And a problem are things, it can be anything, right? It can be hailing a taxi, it can be finding a place to stay, it can be communicating with friends over long distances, anything. And then we have to come up with a solution. That could be something like Facebook, Uber, Twitter. You get the idea. And from that, we hopefully eventually get money, maybe, or we get fame, also called an exit. In the case of our application that we're going to be building over the next 100 episodes or so, is we want to be able to leave behind a letter, a note, a video, anything if something happens to us. And this is not this is a somewhat simple problem to solve in the real world. You can leave a letter with a friend and say, "Hey, if I don't come back, like give this to my mom," or you can do all kinds of things. And I travel a lot for work, so for me, I want to be able to automate this in some way so that if something happens to me, then my wife can get a letter with certain passwords or whatever, and I can leave a letter to my son saying like, "Awesome, watching you grow up" or something. So how do we get from a problem to a solution? We have an idea of an app in our head. Like in my case, I want to build something that can let me leave letters behind in case something happens. I go on a hike or I fall out of an airplane or whatever. That's our solution. Interestingly, our exit is probably nothing because this is going to be a free app. It's going to be professionally done and it's going to be pretty awesome. Each of these things has a lot to do in them. For example, the problem, we've kind of already identified it, but you can easily spend several years coming up with a problem worth doing. Because here's the thing, if you have a problem and you come up with a solution, you have to be dedicated to it. And it can be hard sometimes to come up with a problem worth dedicating yourself and your free time and time away from your friends to actually implement the solution. So let's talk about the solution. And the solution is this is what I do for a living. So I can kind of explain what goes on behind the scenes when you're building an app from scratch. And it's not entirely too complicated, honestly. So you essentially, from the beginning, the first step you have is defining the problem. And believe it or not, the actual creation of the solution involves doing this over and over and over again until you end up with the solution itself. In a way, the actual solution is holographic to the problem. But anyway, back to what I was saying. You first define the problem, and then B, you define how the solution will be used. And that seems like it's a fairly straightforward task. Just think about how it's going to be used, right? But the higher up you are in abstraction, hey, when you're dealing with project managers, designers, and stuff like that, it can be very, very subjective. However, when you get down into the nit and the grit of the actual software itself, it can be super objective. There is a better way or the best way to do something in the software itself. So once you've defined how the solution will be used, you need to actually implement the solution, which, believe it or not, the solution comes back to defining the problem. Oh, wait, I did skip a step. The next step after that is checking the solution. We'll get into that in just a second. Let me tie up some ends here. Right. So now we need to actually check the solution. And checking the solution can be anything from automated testing to making sure users can actually use the app to accomplish the goal that you're trying to, or solve the problem that you're trying to solve, to putting it out on the market and seeing if it sells. Like, this is the flow that you follow constantly, over and over and over again, at various levels of abstraction. And what I mean by levels of abstraction is, first you'll define the problem, which we kind of already did. We said, hey, the app's goal is to send a letter. We define how the solution will be used. Well, you'll create lockboxes. We haven't really gotten into this, but we're going to create lockboxes. The users can upload things to the lockboxes, and then they get released when certain conditions happen. And then we'll implement. So now we step into a layer of abstraction. Now we say, okay, cool. Let's define the problem. We need to, what the hell is a lockbox? What kind of triggers are we talking about? Who are the users? How do they log in? And so forth and so on. And then you'll go, okay, I want to create a login page. So you go, okay, cool. Now we step into, you know what? I think this is actually slightly wrong. I think it should go C to A. Yeah. Implement the solution, which goes into defining the problem, which goes into defining how the solution will be. And eventually you get down to, I need an algorithm that accomplishes X goal, and then you figure out what that algorithm is, and then you implement the algorithm, and you step through that just constantly until you end up with a finished product. And it's a lot of work. All right, so let's take a step back and actually look at our app and figure out how that all goes together. So let's think about from a stakeholder and project manager perspective. First off, I kind of detailed a little bit of the problem. Like, I want people to be able to create letters, maybe upload videos or pictures, and be able to share them with people in the event they cannot share them. Another use case might be like a undercover reporter or an undercover cop who, if they're found out, they want to release documents to the world. So we can kind of think of it in that perspective because it's much simpler, a much simpler kind of landscape of what we want to happen. So let's kind of create a flowchart of like how a user. Do we want a flowchart or maybe a state diagram? We can definitely do this with a state diagram, but I think a flowchart might be more intuitive. So let's do that. Let's start with start with a user signs up, and we'll just call when they sign up, user account is created. And then they create a lockbox or something. Is that how this works? I think it might be easier just to modify the existing one it gives us and then Yeah. Oh, it's 2 dashes. So user signs up, we create the account, and then they can create a lockbox. And then, you know, they upload documents. Then from there, we want to kind of maybe have the diamonds for a decision. And then if they are okay, then it just goes back to D. Or no, back to D. Yeah. All right. And then otherwise, no. We release the documents. So essentially, that's the general flow, I guess, of the path that a user kind of takes. And then they can kind of on where we create a lockbox. We can kind of create multiple lockboxes. We can upload multiple documents, create lockboxes. So, okay. I think this kind of explains the overall view of how like something works. And another thing to think about is you know, a user receives a lockbox and yeah, maybe specify that it's a different user. Yeah. Okay. So we can kind of graph out the overall gist of how this works. There's a lot of hidden complexity here. One is signing up and authentication. That kind of stuff like is fairly simple if we're using like a library or using something that we can kind of delve into a little bit when we get there. Creating a lockbox, that sounds remarkably like CRUD, so it should be fairly simple. Permissions and stuff like that we need to think about when we get there as well. Uploading documents, that sounds like it could be fairly straightforward and fairly complicated. I think there's definitely a lot of hidden complexity here. Uploading a document should be fairly straightforward and simple, but it's really not because we need wherever we upload it to, we probably want it to go into the cloud. We need to make sure that it's not readable by everyone. We also need to kind of think about like how we're going to handle catastrophic failures of the data storage itself. That might be fairly straightforward in a cloud environment. We also need to think about like how we're going to store it cheaply. Cost definitely needs to be a factor here. if it's going to be free, we don't want to be paying thousands of dollars a month to run it. We probably want to stick around maybe $100 a month to run it. So uploading the documents, again, I think there's a lot of hidden complexity there. What we can kind of do to ensure that cost is low, I think we can cover that in just a moment. Now let's talk about user is okay. This kind of also seems subtly interesting. Like we probably want to add a couple extra steps here. Like the user is okay. No, then we actually probably want okay. We also probably want to check uh, um, we also probably want to check that they're not okay. um, so like this might be like an email or something that requires the user to kind of say, okay, yeah, I'm actually not okay. You can send this lockbox. And a no response would be the same as saying I'm not okay. Coming up with an idea of what is an okay amount of time to wait, because not everyone checks their email every day. And also, you probably want certain situations to be a very much shorter situation, or maybe even allowing disable confirmation altogether. And you can kind of think of this like in a hiking scenario where you do want it to email and wait 24 hours in case you're okay, or you don't want it to wait 24 hours. You want it to just send if you're not okay, if you don't check in or something. And that kind of comes back to the user is okay part. Like what how do we determine whether or not a user is okay? What does that even mean? In my particular custom bit of software that I have running, user is not okay means my laptop didn't turn on for over 24 hours. And that's because I always have my laptop on. I'm always working or playing games or doing something. So if my laptop doesn't check in, then I'm probably not okay. And it's definitely led to some interesting situations because I do oops. Oh, well, we don't want to release the documents until after. Yeah, so that's better. So now we confirm it's not okay, and then we release the documents. Otherwise, we go back up to here. So, all right, as I was saying, user is okay, and confirming the user is not okay. We kind of need to think about what that actually means. And I think it's actually a problem that we can kind of push down the road a little bit. Like, the user is not okay kind of lends itself to either, some kind of email check-in, some kind of SMS check-in, or just having some kind of password or something, and it's not super clear on what that actually means. But that is a problem that can actually be solved later. The problems up here are fairly big and can kind of easily take up the rest of the stream and then some. The other thing to kind of think about is confirming user is not okay, releasing documents. Those are also problems that can kind of be pushed down to later, but releasing documents should be fairly simple. It's just enabling more permissions on the actual documents or lockbox, and should be fairly straightforward, I would think. And then sending an email saying, hey, your lockbox has been released to user B. So I think this is fairly straightforward, I think. I think we can definitely just kind of use this here. Okay. So let's talk about infrastructure and stuff like that. I'm actually going to Yeah, let's talk about infrastructure. Like, what does infrastructure even mean? We're going to switch over to InkDrop, which is basically a note-taking application that allows you to kind of do markdown related stuff. It's super handy, and we can kind of just write and mark down what we're thinking of here. So infrastructure for Swytch, which is what I'm calling it, it's kind of based a play on Dead Man Swytch, which is what this software essentially is. So let's talk about infrastructure. We want it to be cheap. Um, we want it to be cheap. We uh, want it to be fast, and we want it to be easy to maintain and extend. Since we want it to be cheap and we want it to be fast and easy to be extended and maintained, let's think about using serverless. And do we want to maintain our own servers, or do we want to use some kind of platform? I'm thinking that we probably want to use Azure, Microsoft Azure. And the reason for that is they are definitely in the top 3, I would say. And secondly, I use AWS at work. So I want to kind of expand my playing field a little bit and use something that I wouldn't normally use at work. And the reason for that is just experience, right? Like if I do happen to ever switch jobs, then I want to kind of be able to say that I have experience in both of these platforms instead of just one. It kind of opens and expands the doors of what I have available. So Azure has Azure Functions, which is a serverless platform. That's kind of pay as you go. So it should be really cheap if I have no users, and it should continue to scale beyond that. At some point, it might make sense to switch to more of a traditional platform or not. But for getting started, definitely serverless makes a lot of sense. It also means that we're going to be writing in C#, which is good. Definitely not a bad thing. We could also choose to run it in JavaScript or Python, maybe even like Go or something like that. So then we need to talk about, so the API will most likely run there. Now we need to talk about the front end. So using Azure Functions, let's go with C#. It's well typed and pretty easy to kind of mess around with. We can do it's a general purpose language. We can kind of pretty much do anything with that. Now for the front end, obviously it makes sense to use JavaScript, or does it? We could do something in React, and in fact for the apps, we can definitely use React Native. That just makes a lot of sense. I don't spend a lot of time writing apps, so writing a completely native app is probably out of scope for this project. But JavaScript, no. JavaScript is great, but we have to think about our users. Actually, let's take a step back and let's talk about users. What will our users look like? What is their demographic? What is their use case? Our users will most likely be older, right? I would think. Like, all right, actually, let's take a step back a minute. personally, I didn't start feeling mortal until I was in my 30s. Maybe even late 20s. I kind of knew that I was mortal, but it wasn't definitely when I was 18, between 18 and 25, mortality was not even a consideration on my mind. And it wasn't until like I started gaining assets and started, dating more seriously and started kind of building a family that I actually felt mortal and realized that one day I'm going to die. So yeah, I would say our demographic will be uh, maybe 25 plus. They're probably going to have a little bit of income, maybe more toward more towards having money than without. Um, yeah, I think we're kind of going after that polished feel with the UI. So I definitely think they're going to be more uh, luxury driven. Maybe would be a good way to say that. Uh, use cases. Let's talk about that. Use cases are definitely going to be uh, people who travel. So, like, the traveling salesman, maybe. Uh, definitely, definitely be hikers who kind of want to hike alone, but also leave some kind of breadcrumbs behind of where they're going and what they're doing. Like I definitely, when I hike by myself, I don't really think about this much. So it's going to be kind of interesting. Uh, People who are sick, definitely, definitely be here. When you're sick, though, I think you're more likely going to lend yourself to more traditional approaches and not really trust technology to be there for you. Um, it's much simpler just to leave a letter. So actually, maybe not. Um, yeah, spies, uh, undercover journalists, and cops. They probably have their own system in place, but this is definitely something that could cater towards that group. Um, and could be interesting. Could also open us up to various government situations, but I don't think it's really a problem. Um, let's talk about some user considerations. Privacy will be a big one. So we definitely need to be considerate of people's privacy. Um, that means that we probably want to make sure everything is encrypted so that even as a developer, I cannot read what is written here to our users, families, and so forth. It could even include medical information, so we need to consider things like HIPAA and making sure that we're secure and can't be hacked very easily. So privacy and stuff like that is definitely something to be considerate of. Also, we need to be considerate of security, which is a given, but worth listing. We also want to be thinking about uh, other things as well. I think this is good enough for now to get started with. We can probably kind of think about other considerations as we go. And we can actually, what I'm going to do offline is I'm going to actually sketch out some user profiles. So the reason that you might at your job have someone develop user profiles is so that you can communicate how users are using the application. You can think and make sure that whatever product you're building can cover those use cases. So I'll do that offline and cover that on the next episode. But back to the front end, we think that our users are probably going to be older. So JavaScript may not be a given. We also expect people to be maybe less technically inclined or more technically inclined. I kind of expect a range there. So I don't think JavaScript should be a requirement to use our application. And that means we need to have everything built server side for the web. And what does that mean? That means that let's look at using something like PHP or what's another web specific language. So here's the thing. I kind of need to just like take a step back for a second, and that I am not your normal programmer. I choose languages based off of, one, do I know them, and do I know them well, and two, do they actually serve the problem I'm trying to solve. Like, you wouldn't use PHP to do machine learning, for example, because PHP is specifically designed as a sort of templating language for the web. So I think PHP makes a lot of sense, and we're just going to use it strictly for templating. We could use something like Blazor or Razor in C#, and that's definitely a possibility maybe later on. But PHP has a lot of things built into it. We can literally compile PHP to the CLR that C# runs on, so it can be running native, compiled into the actual C# code, which is actually really cool. So I think it makes a lot of sense to just like, let's do it. Let's just use PHP for now. If it turns out to be kind of a disaster, then we'll regroup. That also allows us to use something like WordPress to kind of handle the CMS side of things, and could be some really cool stuff that we can do later on. Now, let's talk about databases and caches. For databases, we want something fast. And we want something redundant. So we want redundancy. And I think we can actually get redundancy through almost any cloud provider that can allow us to recover from some kind of catastrophic failure. There's so in Azure land, we can use SQL Server, we can use Postgres, we can use MySQL, we can use Cosmos DB, we can use a little known something called durable functions. We can use table storage. So there's a lot here that we kind of can go with. So let's think about SQL Server for a moment. SQL Server gives us redundancy. It gives us all the things that we need. It has great integration. It has it's battle tested. Some of the cons, we can definitely have some SQL injection issues. Same thing with Postgres, MySQL. Cosmos DB has a really cool multi-master replication, kind of giving us a worldwide distribution. Durable functions is actually really cool in that it just works. And I think this is what we're probably going to go with. Because these other things, they have all the things that we need, but it's kind of overkill. This is a CRUD application, meaning that we can know all the IDs of all the things that we need. We kind of want the ability to hook into how things are stored, giving us essentially triggers for free. Cosmos DB kind of gives that, but it forces us to kind of build on it and not in it. So we'll use durable functions, and that kind of gets us the best of Cosmos DB, the best of SQL Server. We'll have to build indices ourselves. We'll have to kind of think about how we want to do migrations and stuff as we're building. But all in all, I think it gives us the best of everything that we want to be able to do. For caches, let's consider this not needed right now. But we'll probably just use Redis. So I think that covers like all the cases that we have for being able to just kind of start moving forward. Do we want to use REST or GraphQL? And we can kind of cross that bridge when we get there. I think it'll be fine to use REST because, again, it is much like a CRUD application. GraphQL, I don't know though. It is kind of a graph. Like if you think about it, lockboxes contains files, files contain attributes, and I don't know. You could definitely argue that it's a GraphQL application, but we'll kind of cross that bridge when we get there. We're not going to even have an API until we start building the apps. So that's definitely a problem that we can solve later. And we can kind of just worry about building an application first, seeing what it looks like, and kind of dig into the rest as we go. Right. Cool. So I think we kind of have an idea of what we're building a little bit, and we kind of have an idea of how it will work a little bit. There's definitely some like some things that can be kind of fleshed out more, but I feel like we're not going to be able to solve them right this second. There's a lot to think about and a lot to do. In the meantime, I think we can go ahead and start looking at programming it a little bit. So this is Azure Functions. It's pretty simple. We have a very simple function here. It takes a get or a post, and let's want it to be anonymous. And we basically log that, hey, we processed a request. We get a query variable called name, and we read the body, deserialize the object, see if it has a name, and what? All right, so Siri apparently saying deserialize triggered Siri. That was great. So we take if it has a data name, or if it has a JSON object with a name key in it, then we store that name, and we basically say, okay, cool. We, if name is not set, then we basically say, hey, we didn't get anything. Pass a name in. We pass a name. We say hello. We execute successfully, and then we return said message. So this is super straightforward, not that complicated. Now, there's a lot of things we have to do. A lot of things we have to do. Should be pretty straightforward. Like, at this point, I think it's worth kind of doing a little bit of project planning. We have an Azure function, but we need to know what to do next. We need to know what order to do it. So it's a good time to step back and instead of cowboy coding this, actually project plan or plan the project like we normally would, and think about what we need to build and in what order, and be able to track any kind of bugs that we discover along the way and prioritize fixing those bugs over other features that may conflict. So let's do that. What are we going to use for project planning? And I think one thing that we need to think about when we're project planning is one, ease of use in what we're building, and kind of thinking about what we need to do next. We could use GitHub issues, but in my experience, GitHub issues does a fairly poor job of allowing you to kind of think about scheduling and think about big picture planning. The GitHub projects view is also pretty good at handling that aspect, allowing you to kind of prioritize things. However, it definitely could use some work. All right. So let's get over to doing some project planning. All right. So interestingly, I have a super old Pivotal Tracker account. So let's use Pivotal Tracker. It kind of allows us to kind of think about backlogs and kind of think about how things are going to kind of work. Now, I plan on doing this, posting or recording up every Monday, as well as posting a live stream on Twitch every Wednesday. We'll see how that kind of works out, but let's get into deciding what and how this will work. So the description of the project is a dead man Swytch. Cool. We don't want it to be public access, at least right now. We'll go ahead and start iterations on Monday. This project start date will be today. We'll keep our time zone. We'll keep the iterations down to weeks, and we'll think about how hard something is in a Fibonacci sequence. We'll go ahead and start the initial velocity at maybe 3. And we'll use the average iterations of 3 iterations. We'll keep automatic plan on. We'll keep an API access. Go ahead and do allow incoming emails, and no bugs and chores will not be given points. We'll save this. All right. Saved. Profile, we'll leave that alone. We don't need any webhooks yet, or stories, or templates. That sounds useful. Oh. Template name, template description. Well, I'll play with that later. View types. We'll keep these and actually try to do each of these reviews as we go. So let's create a story. It should be fairly simple. Let's think about this in terms of what we want the user to be able to do. First up, the user should be able to log in. That's pretty straightforward. We will leave it unestimated at the moment. Our description should definitely be something like the user should be able to see a login page and be able to log in with Google. Labels. Seems like perfect label will be login. There's no code yet, and there's no activity, so easy enough. Let's kind of go back to this. So we should be able to, log in, and that should create the account. We should be able to create a lockbox. We'll leave that unestimated as well. Let's see, a user should be able to create an empty lockbox. Yeah. And call this, label it lockbox, save. Come back over here. The user should be able to upload items to a lockbox. This has the lockbox label and uploads. Thing about this, so a user should be able to choose people to release a lockbox to. And do we need a description? I don't think so. I think it's kind of self-descriptive for now. Confirm a user is not okay. This is actually going to be a chore because we don't know yet. So we're going to investigate how to release a lockbox. Because we don't know yet. Right? Right. Okay. So now that we have this stuff, top of the list, user needs to be able to log in. User needs to be able to create a lockbox. A user be able to upload items to a lockbox and choose who to release a lockbox to. We'll leave that down at the bottom and call it a day. Cool. So let's think about how hard login will be. A 0 means that it's so easy that you don't even have to think about how hard it is. A 1 means that you have an exact idea of how to implement it. You just need to actually do the work. It's not hard, but it's also not easy. Like, for example, mailing a letter, right? A 0 would be writing the address on it. It's easy. You have the address. You just need to write it on the envelope. That's how easy it is. 1 is actually going to the post office or going to your mailbox and putting it in the mailbox. You know it's super easy. You just need to do it. You know that there's not probably going to be any unexpected situations coming. Like maybe you don't have money for a stamp, so you have to run and go get some cash or whatever. So in that case, like, there's something that might happen, but you know how to solve whatever happens. Now a 2 is twice as hard. It's maybe mailing a package to another country. You don't know if there's you know that there's probably some customs forms to fill out. You know what the problems are. The problems are not going to be super easy. Like on a customs form, you might have to fill out a bunch of stuff, but you know this going into it. and you know where to get the information, and you're kind of comfortable doing that. A 3 is the exact opposite. You're told to go mail something to an international customer, but you have no idea what that entails. It requires a little bit of research, but you have a pretty good idea that it should be fairly straightforward. A 5, on the other hand, is you have no idea. You're asked to mail something. You don't know where it's going. You don't know what all of it entails. So you kind of need to wing it. Some investigation is required to complete the task, but you also know that many people have done this before and it should be fairly straightforward. An 8 means you have no idea. You're just given a box. You don't know what to do with the box. Do you mail it? Do you ship it? Do you take it to someone's house? Like, you have no idea what it entails to continue. This is usually a red flag that this task is not going to survive as is. It needs to be broken down into smaller tasks and approached in that sort of form. A 5 is very similar to an 8, and that should probably be broken down into subtasks and kind of addressed in that situation. For a user being able to log in, I believe that's going to be something like a 3. I have a pretty good idea of everything that needs to be done, but there's definitely going to be some research involved. There's definitely going to be, thinking about how things work and flow from the beginning. So let's definitely kind of consider this. A user should be able to log in as a 3. It's going to require a bit of work. A user should be able to create a lockbox. If this is a CRUD app, which it is, this should be ridiculously straightforward. We save the data into the database, we return it to the user, and the user can then navigate to that page and create a lockbox. So I wouldn't say this is a 1, definitely a 2, because we're going to be using durable functions. So there's going to be a tiny, tiny bit of research required, but it's also super easy, not very hard at all. So we'll just call that a 2. A user should be able to upload items to a lockbox. This is not straightforward at all. I can tell you that just from the get-go. Like, if we were just uploading it to the server's local file storage, this would be dead easy. This would be incredibly easy, but we need to be thinking about it from the aspect of we're going to be uploading this probably to a separate storage system than where the app is currently running. This means we're probably going to need to think about how that all kind of flows, and we need to be thinking about how, where, and if it arrives at the destination, we need to think about encryption. We need to think about maybe transcribing any videos. We need to be thinking about, how we're going to store this in the file system itself, like what folder everything kind of goes into. And we need to be thinking about any kind of file system limits. All those kind of things are questions that need to be answered that we don't know the answer to right now. So we're going to consider this a 5 or maybe even an 8. It needs to be broken down further. It needs to be more understood as to what our limits and capabilities are. So let's call it a 5. A user should be able to choose people to release a lockbox to. This sounds incredibly straightforward, not complicated at all. I am somewhere between a 1 and a 2 because it sounds so easy that I think there's something else going on here. So let's call it a 2. And then we'll have to investigate how to release a lockbox. So all in all, this is a pretty simple set of tasks. It looks like it'll keep us busy for a few weeks. And once we kind of get going, and this estimation will be even more accurate. But yeah, so it's looking like we'll be working on this all week. Let's go ahead and start it, actually. So now the clock is running, and we can kind of be able to see as we go. We'll be able to kind of see how things are moving along and so forth and so on. Now, I do kind of want to take a moment to think about the first iteration. Let's call it an MVP, able to upload. And we will call this a release. And let's actually give us a release date of the end of October. We'll give it a release label. Finish. Oops. Move it back to started. And save this. And move it down here. Right now it's blue, meaning that we are, in fact, probably going to accomplish all of our tasks that we've set out. In fact, it looks like we'll be finished the 25th of October if we're able to complete 5 points a week. That is remarkably a low amount of work to be done, and should be able to accomplish this, I think. We'll see. All right. I believe this will conclude the first episode. On Wednesday on Twitch, I plan on uploading or streaming, actually building this system and making it so a user can log in. Remember, this is a 3-point task. It should be fairly simple, but there's a lot of hidden complexity here. We need to set up the function app to render PHP, which seems a little bit insane, but we'll give it a shot. Maybe we'll just use something like Blazor or Razor. The other thing will be tying up, durable functions and figuring out how all that works, and being able to run everything locally, which will also be super interesting to kind of move forward. One thing that we'll probably talk about in next week's YouTube episode is planning out the states for a lockbox and planning out how things start to release. So we'll actually be starting to investigate then. Then next Wednesday, we should be spending time. A user should be able to create a lockbox. That should be next week. We'll see how it goes, and make sure to follow, subscribe, and do all that kind of stuff if you're interested in seeing how this all works. Cheers, and have a good day.